Good morning and good evening, everyone. So welcome back. So yesterday we discussed two things, that is TF-VARs. So TF-VARs is used to replace default values in variables. Okay, or if value is not specified, values are not specified in variables.tf, we can supply values from here. So if you specify the values in variables.tf default keyword, so those values can be replaced by TF-VARs. So usually terraform.tf-VARs, you can keep it any name you want. So if you keep different name, you need to pass through the command line option -var file equal to what is your file name. Okay, and it is used to create multi-environment infra. Okay, so we can control through different variable values, okay, and different state. Okay, so these are the two things actually we have seen using TF-VARs, and then we went for module creation. It is based on the principle: try, don't repeat yourself, keep the code centralized. Okay, you can refer the code as many times as you want. Okay, so yesterday we have seen a simple example using EC2 and security group, right? So the keyword is, so nothing but it's very simple. So your module is here. It means your code is here. No need to keep the provider. Okay, provider will be supplied by the actual user. For example, you are the module developer. You are the Terraform developer here. Okay, so you are creating EC2 and you are creating variables, and so whatever the variables here you declare, so user should supply this. Okay, you can keep default values here. Okay, for example, you can keep default values. You can keep default values. If user is not supplying, you can use default values. Okay, so you can use this. This is the module, and then name of your module. You can keep whatever you want, and you need to supply the source. Where is the source code? Where is the actual code exist? And you need to supply the values for those variables. Okay, so very simple. No difference than actual resource creation. It is exactly same, but you are keeping it the code in centralized place, and you are referring it from different repositories. Okay, so ideally you can keep one Terraform modules -EC2 in our entire company, and any number of projects we can refer the source like this. Okay, you don't need to create the source code again and again. So that is the module development. Okay, it is not a Terraform concept. It's I mean, it is not a, this dry is not a Terraform concept. This is the simple general programming concept. Okay, not only in Terraform, we have seen this in Ansible. You can see this in Java everywhere. Okay, so in Java we call this as jar, right? Jar files. So these are libraries. So again, the concept is same. You no need to create code from the scratch. Okay, you can simply refer from internet. Okay, in package.json, so we have dependencies that also follow the same concept. Okay, so today we will start with our AWS concepts. First AWS concept we discuss is VPC, Virtual Private Cloud. Okay, so we'll say this before discussing about VPC, we need to understand the IP address. Okay, IPv4. So IPv4 address consists of 32 bits. Okay, divided into 4 octets. Each octet consists of 8 bits. Okay, so this is the IPv4 structure generally. So let us just think, how can we create IP address? If you have 1 bit, okay, so this is 1 bit. So, in computers, we have the binary programming, binary system that is nothing but 0 and 1. Binary means two digits. So we will have 0, 1. Similarly, we have decimal, right? What is decimal? Whatever the system we are now using, this is decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 99, 100. These are all decimal number system. So again, decimal number, you will have 10 digits. Deci means 10. So any system, it will start from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, binary means 2 digits, then it will start from 0 and 1. Decimal means 10 digits, it will start from 0 to 9. Okay, so if you take, now let us understand binary system. So if I give you 1 bit, how can you fill this? You can fill this with either 0 or 1. Okay, so if I give you 2 bits, so these are the combinations, possible combinations. Okay, you have 2 bits. So how can you fill this? 0, 0, and then 0, 1, 1, 0, 1, 1. So these are the combinations, right? You can say this 0, 0, 0, 1, 1, 0, 1, 1. And let us start with 3 bits. Okay, you can type parallelly with me 0, 0, 0. And type parallelly with me 0, 0, 1. Okay, so the logic is simple. First, let us concentrate on the last bit 0 and 1. So now 0, 1, 0. Zero, 1, 1. Zero, and then 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Okay, for example, 1, 0, 0, 1, 0, 1, 1, 1, 1. Okay, how many are there? 4, 5, 6, 7. And then, so before this, we will have 1, 1, 0. Okay, so these are the combinations. So we have 8 combinations. So now the formula you should understand is, in binary system, if you have n bits, you can generate 2 power n combinations. Okay, so if you have 32 bits, you can generate 2 power 32 combinations. That is nothing but 4.3 billion. Okay, so if you have 32 bits in our IP address, so you can always generate 2 power 32 IP address. And remember this, okay, if you have n bits, 3 bits, you can generate 2 power 3, 8. If you have 4 bits, you can generate 2 power 4. 16 possible number. Okay, so this is the base for our enter IP address in our software. Okay, so again, so for 0.3 billion IPv4 address, initially we had like, so when you take internet to your home, so you are getting different IP address for your different device. For example, if you had mobiles at that time, you will get one IP address for your mobile. If you will get one IP address for your laptop, you will get one IP address for your TV, and you will get another IP address for your refrigerator. So this was the case in 1980s. Okay, 1980s, till 1980s, the IP address was allocated like this. And at some point of time, they understood if we keep on allocating the IP address like this in future, so these 2 power 32 IP address will not be sufficient. Right now, the population of the world is around 8 billion. Okay, and every person has at least one mobile, and then we had multiple electronic devices like servers and then refrigerators are all connected to internet. If your device is connecting to internet, definitely it needs the IP address. Remember this. Okay, if your TV is connecting to the internet, it needs an IP address. Okay, if a refrigerator, everything is becoming very smart. Our cars, automated cars, every device in the world, if it is computing electronic device, definitely it need IP address nowadays. So IPv4 address is going to be exhausted. So everyone was saying like this. Why it is exhausted? Because these IP addresses are not sufficient. So at that time, 1980s, they understood these IP addresses are not going to be sufficient if we keep on giving the public IP address to the devices. So then they introduced a concept called private IP. Okay. So private IP, how you will get it is, if you take an internet connection, you will get one public IP address to your modem, and then your modem will have one private IP address like this. We can call this as default gateway, and any device connecting to that modem, it will get private IP address. It will not get public IP address. Okay, all the devices, your laptops, your mobiles in your home, like your TV, everything is getting private IPv4 address from modem, and this modem will have public public IP address. Okay, if you just type here, what is my IP, then you'll get this is the public IP. Okay, and if you type IP config in your laptop command prompt, okay, so this is the modem IP address, and this is my laptop IP address. Okay, so the same I wrote here. This is my modem, so this is my laptop IP address. Now, if you keep on connecting the devices to this modem, you will be getting private IP address. If the communication is going outside of your network, for example, if you search facebook.com or whatever you do here, so if the data is going out of your modem to the outside world, then the communication is based on the public IPv4 address. This is called as NAT, network address translation. Okay, so now what is network? So network is generally logical, not a physical thing, okay, right? So you will get lot of devices. This is your home network, okay? So and you have your devices. For example, if a neighbor is there for you, if a neighbor is there to you, they cannot connect to your systems because your network is isolated from their network. So usually in our companies, we have a huge data centers, that is company network. And in government office, they have one network. So that is their network, local network, whatever it is, okay? So every network is isolated from different networks by default. If you want to allow the traffic from the outside world, you can allow, okay? So I'm sitting here, you are sitting somewhere in India or somewhere in the world. I cannot connect to your laptop. I cannot get the information from your laptop easily. So that means your network is isolated. Okay, so ideally every network is isolated. So inside the network, you can have any number of devices. Okay, so now let us discuss a simple concept. So we have 2 bits. Okay, here we have 2 bits. Here, if I select 1 bit, then how many parts I can divide? I can divide entire system. Okay. So how many parts I can divide if I select one bit? Anybody can type. Okay, let me take paint. So 0, 0. Today it may be theoretical for half time. 0, 0, 0, 1, 1, 0, 1, 1, right? So if you select one bit, I can divide it into two parts. Okay. So first part starting with 0. And then second part starting with 1. Okay, so like this, you can divide into two parts. Similarly, if you have 3 bits, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so these are the 8 bits, right? So this is 3 bits. Sorry, this is 3 bits. How many combinations you get? 2 power 3. That is nothing but 8. So now if you select one bit, how many parts you can divide here? Okay, you can type in the chat. If you select one bit, I can divide it into two parts. First part starting with 0, second part starting with 1. Okay. Now, if I select 2 bits, how many parts I can divide? If I select 2 bits, how many parts I can divide? 4 parts. This is one part, and this is one part. This is one part, and this is one part. Okay. So first part here, first part starting with 0, 0. Second starting with 0, 1. Third starting with 1, 0. Fourth starting with 1, 1. Okay. If I select 3 bits, how many parts I can divide? Okay, obviously 8. This is 1, this is 1, this is 1, so this is 1, this is 1, this is 1, this is 1. So 8 parts. Okay, so now a simple formula again here is let me take this. If I select 2 bits, I can divide into, if I select n bits, let us take n bits, can divide into 2 power n parts. Okay, so for example, let us take, we have k parts in total. Out of this, if you select n bits, how many parts you can divide? Parts equal to 2 power 2 power n. Okay, so each part contains two power k minus n. Okay, so let us see. K equal to 8 total bits, that is equal to total bits. Okay, if you select n equal to 1, how many parts? Parts equal to 2 power 1. That is nothing but 2 parts. Each part equal to 2 power k minus n. 2 power 8 minus 2. No. Okay. So out of 2 bits, okay, 2 bits, where is this 2 bits? Yeah, this blue color. Each part contains 2 power n minus 1. Sorry. Each part contains 2 power 2 minus 1. So that is 2. Total parts equal to, sorry, it is 2 power 2. Okay, we are working with 1, right? Yeah. So 2 power 1. Sorry, this is something wrong here. Okay, leave about the formula. So when I select 2 bits, I'm getting 4 parts. That is nothing but 2 power 2. Okay, 2 power n. Okay, let me take 2. Okay, total 8 bits, and I'm selecting 2 bits. Okay, total number of parts equal to 2 power 2. And then each part will contain let's select 2 power, simply missed it. Can someone remember to the formula? I cannot understand and derive from here. Parts equal to 2 generally. Parts equal to 4. And each part has 2 numbers. Sorry. This is k equal to 3 total bits. Sorry for the confusion. So let us take once again. Here I gave different number. So how many bits we have here? 3 bits. Okay, k equal to 3 total bits. N equal to 2. So out of 3, I'm selecting 2. Okay, so parts equal to obviously 2 power 2. We know this. Okay, this is the part. And each part contains 2 power k minus n. So that is nothing but 2 power 3 minus 2. I'll just give like this so that we will not confuse. That is nothing but 2. Okay, so you no need to remember this formula actually, just for our understanding right now. I'm telling like this, even I don't remember. frankly. Okay. So now let us take total number of bits equal to k. Let us take 4 bits. How many total numbers is possible? Can someone type? Total numbers possible out of 4 bits. 2 power 4. That is nothing but 16 bits. Okay. If I select 2 bits, okay, so that equal to n equal to 2. How many parts? 2 power 2. That is nothing but 4 parts. Okay. And each part contains 2 power 4 minus 2. 4 numbers. Okay. So now the calculation is correct, right? 4 into 4, 16. Okay, so this is the base for CIDR calculation. So what is CIDR finally? CIDR is classless inter-domain routing. Okay. So why we need CIDR? So for example, let us take this like government buildings in our capital, Delhi, for example. So all the government buildings are in one area, for example, one street maybe. So you will have public, so where public can meet the officials, central government officials or ministries, and then inside we will have central government. Each ministry has its own building, like Home Affairs, Sectional Affairs, and then other ministries like aviation, and then finally we have Prime Minister office also. So if you just think like, let us just think, so you can have a road, to reach the government buildings, and you are not allowed to every area inside the building because of security. So maybe you are allowed, there will be office like public can come and then complain against something. You can go to that public space, and there we may have some officials, government officials. You can give some complaints, some notifications, some whatever you want. Okay, some recommendations you can go and submit, and you can come back. But you are not allowed to enter into other areas like ministries, prime minister, and then our president. You are not allowed to enter. Why? Because that is the security mechanism we have applied in this area. Okay. Similarly, you will have a lot of servers. We have web servers, we have application servers, we have database servers. Our users are not allowed for everything. For example, we are publishing our RoboShop into the online. So users are not able to see what is inside the database. They are only allowed to see what that website is offering. For example, if I type amazon.in, here I'm not able to see the Amazon database, but I'm able to see the items inside in this website. Okay. So similarly, generally you are not allowed to enter into the, like, let us take this as a network. You are not allowed to directly connect to the databases, directly connect to the API tier or app tier. Okay, you are only allowed for the public space. That is nothing but web tier on port number 80 or port number 443. Okay, so you are not allowed to talk to another app servers or database servers. Okay, you are allowed only to the web server, that too on port number 80. Okay, you will not get port number 22. You will not get other ports. Okay, you will only get the public port, which is like HTTP port, port number 80 or port number 443. So this is possible because of the network isolation. So inside a big network, okay, we have a big network. You get a big network generally. We will discuss that. You get a big network. You need to divide it into multiple subnets logically. So here we got a big space to construct our government buildings, and then the government will construct like this. First, public can easily enter to this space, but from here we will have tight security. No one is allowed to enter generally by default. If you are authorized, then only you can enter till this. home affairs or external affairs. Again, if you want to meet the prime minister, again you need to take some appointments, some recommendations, some lot of prime minister has to give an appointment, everything. So with tight security rules only you can enter till here. Okay, similarly we will have our web tier here, our app tier here, our database tier here. So database tier generally only app tiers only can connect, otherwise web tier also will not able to connect. Okay, public will not able to connect. So this is the network isolation that is called as subnetting. So you'll get a big network and then you need to divide it into small subnets. Okay, so let us see the private IP ranges. I said these are the only private IP ranges you can use. So we discussed, right? So this is the private network, your home network. You will get one private IP address from your modem. Your modem is responsible to give you private IPv4 address for your each device. Okay, so these numbers, okay, so these numbers are called as private IPv4 ranges. We will use, if you, for example, if you see your laptop IP config, you will get like this, either 192.168 or 172 or 10 dot something. Okay, so now let us discuss IP address. So this IP address is a combination of your network ID plus your host ID. Okay, so if I say 10.0.0.0/8, what is this notation? Generally, we call it as CIDR notation, classless inter-domain routing notation. Okay, so what does it mean is first 8 bits are for network, remaining 8 bits are for host. Okay, so we have kept 8 bits are reserved. 8 bits are reserved. You should not touch this. You should not touch 8 bits. So here 8 bits is nothing but 10. Okay, you should not touch this. And remaining 24 bits you can keep it anyhow, you can use it anyhow you want. Okay, let us work on this 24 bits. Okay, so now I want to divide it into 2 parts. How many bits I can select? How many bits I can select? If you want it to 2 parts, can someone type? Yeah, 1 bit. If I select 1 bit, I can divide into 2 power 1, that is nothing but 2 parts. Okay, so now let us work on that. So you should not touch first 8 bits. Okay, this is reserved for the network. And next, this part, right? Let us work on this second octet. Let us take 3, 4, 5. Let me take the paint. Okay, let us work on 8 bits now. One, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 bits. So you can fill this like this: 0, 0, 0, 0, and then 0, 0, 0, 0. And you can type like this also. All the combinations you can keep on fill like this: 0, 0, 0, 0, 0, 0, 0. Sorry, 1, 0. And then 0, 0, 0, 0, 0, 0, 1, 1. Okay, like this you can type. So, and let us start with 1, 1, 0, 0, 0, 5, 6, 7, 8. And then 1, 0, 0, 0, 0, 0, 1. Similarly, 1 0 0 0 0 0 1 0, and then 1 0 0 0 0 0 1 1. So like this can go till 1 1 1 1 1 1 1 1. Okay, so you can divide it into two parts. First part contains all zeros. Okay, for example, here it is 0 1 1 1 1 1 1. Okay, so first part contains all zeros, second part contains all ones starting with. So now the number, if you calculate here how much it is starting from 0. The first part starts with 0 and ends with 0 1 1 1 1 1 1, like this. Okay. So what is this number if you convert binary into decimal? Okay, so let us understand that. First bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit, eighth bit. So this is 2 power 0. This is 2 power 1. I mean the second. This is 2 power 2. The placeholders. This is 2 power 2. So what I mean to say is you come from the back. So this is the 0th position. 0 position. The value here is generally 2 power 0. Okay. First position. The value here is 2 power 1. Second position. The value here is 2 power 2. So like this, we have 7 positions. The value here is 2 power 7. Okay. So third position, it is nothing but 2 power 2. Fourth position, it is nothing but 2 power 3. Fifth position, 2 power 4. Sixth position, 2 power 5. Seventh position, 2 power 6. Okay, so this is how you convert binary number into decimal number. So this value is nothing but 1. So this value is nothing but 2. This value is nothing but 4. Zero, 2 power 0, 2 power 1, 2 power 2, 2 power 3, sorry, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Okay. This is 4. This is 8. This is 16. So this is 32. This is 64. This is 128. Okay. So now if you want to get the range, so it will start from 0 to all ones in this. Okay. If you have 1, how can you calculate this? You have to calculate this one. So this value is nothing but 64, 32. It is 96, 96, 16. It is 112, 120, 124, and then 126, 127. Okay. So 0 to 127 is first part. Okay. and then 128 to 255 is second part. Okay. So now you should divide like this: 10.0.0.0/9, because we selected one bit, and then 10 dot, what is the first digit here? 128. 128.0.0/9. This is the second part. This is first part. So this is nothing but second part. Okay. So like this, you will divide. So when you select one more bit for the network, so this is one network. So this is another network. So generally we call this as subnet. This is subnet. So in a network of 10.0.0.0/8, so this is the VPC CIDR. Okay, I'm calculating two subnets by selecting one bit. Okay, so the first subnet, how can you divide? How can you give the notation is 10.0.0.0/9. It means the first number in this. And the second part, what is the first number? This one. Second subnet. This is nothing but 10.128.0.0/9. Okay, so this is the second subnet. So generally AWS will only allow 16 to 28. 16 to 28. So what is as the idea? Minimum 16, maximum 28. Okay, so you cannot create this in AWS. You have to select minimum 16. That is nothing but 10.0.0.0/16. Okay, and you can select up to /28. So it means you are giving 16 digits for network and remaining 16 for host. Okay, so out of this 2 power 16, so number of host address here is number of host address possible equal to 2 power 16. Okay, so out of this 16 bits, it is our wish. I can select 1 bit, 2 bit, I can do whatever I want. Okay, so generally we used to select 8 bits. How many networks possible? If you select 8 bits out of this 16, 2 power 8, that is nothing but 256 network possible. Okay, same formula again here. K equal to 16. You are selecting n equal to 8 bits. Okay, so how many parts possible? 2 power 8. Each part contains 2 power 16 minus 8. So that is nothing but 256. So this is logical. Okay, there is nothing physical here. Everything is logical as per our understanding. Okay, so now the networks will start. Subnets will start like this: 10.0.1.0/24, because we selected 8 bits. 10.0.2.0/24, 10.0.3.0/24. So like this, it will go around 10.0.4.0/24. So then it will go on 10.0.255.0/24. 0/24. Okay, it is your wish. We are giving you 16 digits to select as your host networks. Okay, it is your wish. If you select 8 bits, if you select 2 bits, if you select keep it the single entire subnet, that is your wish. Okay. So now you can allocate this to the web tier, and you can allocate this to the app tier, and you can allocate this to database tier, and you can allocate this network to another location. For example, Mumbai location web tier. Okay, and then you can allocate this one to Delhi location web tier. Okay, so like this, you will divide a big network into multiple subnets. That is nothing but CIDR. Okay, so now this is the network of web, only web related components. Okay, web related network. So inside this, you can create any number of instances. Now the IP address will come as 10.0.1.0 and 10.0.1.1, 10.0.1.2. So like this, it will go on, and then 10.0.1.255. Okay, total 256 IP addresses. Generally, first one, second one is not useful. It will be useful to notate your network like this, and this one is for the broadcasting purpose. So these two are not useful. Remaining IP address you can use. Okay, so these are called as subnets. So now let us create one VPC. So it's not mandatory to understand everything, whatever I said here. Okay, at least you understand how we are dividing into subnets. Okay, create VPC. Okay, let us create only VPC. I'm creating a VPC for RoboShop. So any new project is started, the first thing they do is creating the network. That is nothing but VPC, virtual private cloud. Okay, so this is where you keep all the resources related to the RoboShop, either EC2, databases, load balancers, security groups, anything. So now the definition of a VPC is, it is AWS virtual private cloud, isolated from other projects. Okay. All project resources can be provisioned here. We have full control. Okay. So just exactly same as your company data center. You are working in a company, they have one network, and it is completely in their network. You go to your a bank like SBI Bank, so they will have one network inside. They will have a modem, so they will have all the wires. They are giving internet to the systems. So that is called as one VPC. So that VPC is completely in their control. Okay, whom to allow, whom not to allow. So like that. So similarly, I am creating a VPC for RoboShop here. This is completely in my control. Okay, for example, I am giving 10.0.0.0/16. If you take 8, AWS will not take it. Okay. So tenancy default, then try to create. It is saying 16 to 28 only. Okay, so you can give 16. There are no charges for VPC creation. Okay, because it is logical, not physical. Just name what is the network range you want. So again, try to select only these things, private IP ranges. Okay, and then create VPC. Okay, so this is, you created VPC. Now you need to calculate subnets. Right now I have 0 subnets. Now I want to create the subnets. How can you create here? Create subnet, select which VPC, RoboShop VPC. and then subnet one. For example, I'm giving web tier, and then here I'm giving it as 10.0.0.0/24. Create subnet, and then you create another subnet. So now this is app, and you create 10.0.1.0/24. You create this, and then for database, you create another. Select VPC, and you create the database, and then you give 10.0.3.0/24. Okay. So now I selected 3 subnets. I can still go on and continue until 255. Okay, but I am keeping this for the future purpose. So for now, I need these many IP addresses are enough for me. These 3 subnets are enough for me. So in future, if you want, you can always go and create multiple. Okay. So this is how the subnets. So now you created this inside, you created a network, and then you created the subnets, but you need internet for this. How can you get internet in AWS? Is nothing but internet gateway, just like your modem. Internet gateway, that is equal to Wi-Fi router. So now here you have something called as internet gateway. Create internet gateway. For example, I'm keeping it as RoboShop, and then create it. So you need to attach it to the VPC. Which VPC? RoboShop VPC. Okay, that's it. So now let us just draw this. I'm creating first VPC. So inside VPC, okay, let me take AWS account. So this is our AWS account. So inside AWS account, we have something called VPC. So this is VPC. I created VPC. Okay, and subnets. We have subnets. So this is one subnet. Okay, and this is another subnet. This is another subnet. Okay, so this is web. This is app. This is DB. Okay, so we have AWS account. I created one VPC. This is nothing but RoboShop VPC. Okay, I created web subnet, app subnet, database subnet. So now you need internet gateway. Okay, so this is generally, this is also internet gateway. So you attached internet gateway to VPC. Yeah, I'm attaching to VPC. Okay. Now we have something called as routes. Routes is nothing but just like a roads. So if you don't have road, you cannot go on from here to here, right? So similarly, here we have something called as routes. Route table and then routes. So now you can go here and then check web. So there is route table. You can see. So by default, all the persons can communicate in this here. For example, here this public space, home affairs, sectional affairs, prime minister. So these officials, they can internally communicate with each other. There will be no restriction. Okay, so that is what it is here. Route table is local. Okay, and then you can see every subnet will have the route table local. Okay, 1 second. So this is the route table. So we have two types of route. One is public route and the other one is private route. Okay, so public route, let us create that. Okay, whenever you create VPC, so there will be a route table created. Okay, so this one. So let me create one route table that is nothing but public route table, and then you select this RoboShop, create route. And then subnet associations. So which subnet you want to allocate to the public? So that is nothing but this one, web. Click on edit and select web, because public wants to open this web, right? I mean, public wants to connect to the web. That is why I am giving route table to the public. And then let us create another private route table. This is RoboShop private route table. So this private route table, you need to attach to the private subnets. This is nothing but app and DB. Okay, and then in public routes, you can see here routes. So just by keeping the name as public, it will not become public. You can just edit the routes here and add route. So that is nothing but this internet. And then this will go through the internet gateway. Okay. So this is the public. Why it is called as public? Just by name, it is not called as public. Okay, you can see this inside routes. So you have something called as internet. This is the internet, and you are going to the internet through this modem. So now it is called as public route table, and this public route table is associated with only web. Okay, now let us go for another private route table. So this private route table, I am not connecting to the internet. So this is very important question in interview. What is public subnet and what is private subnet? If a public subnet is attached to the public route table, then it is called as public subnet. In the public route table, we always have a route that is connecting to the internet. So this route is nothing but a road, for example, a road. So here you have web tier. So you have a road to the public. So this is public subnet, and this is nothing but private subnets. Why these are called as private subnets? Because there is no route to the public. Okay, so these are internal routes. So this is nothing but private route. It will not have public road. It is only have internal routes. Okay, so they may ask what is public subnet or private subnet, or what is public route table or private route table. You should say if a public subnet has a route to the internet, then it is called as public subnet. Private subnet, usually they don't have route to the internet, so it is called as private. Just remember, by naming, it is not function as public or private. It is based on the routes. So what we did till now, we created VPC, we created subnets. Okay, for example, 3 subnets. And then we created internet gateway. And then attached to VPC. Okay, and we created 2 route tables, one public and one private. We associated route tables to subnets. Okay, public route table to public subnet, and private route table to private subnet. Here private subnets are nothing but app and DB. Here public subnets are nothing but web. Yeah, that's it. Okay, so these are the things we created. So now let me delete, okay, and then create through the Terraform. So now I'm creating this VPC. All the resources associated with it also will be deleted. Okay, you can see this. Internet gateway, route table, subnets, everything will be deleted because I'm deleting the entire network. Just delete. Okay, so now let us create something called RoboShop VPC or VPC. Okay, I'm just copying the provider. So here, let me give the backend directly. Backend S3. And then where is it? So this is VPC demo. Okay. So I'm keeping it in RoboShop remote state S3 bucket. The key is VPC demo. I'm logging with DynamoDB. So this is the provider. Now I'm creating VPC.tf. So what is the first resource I should create? VPC. Go to registry, providers, AWS, and then documentation. If you want to just understand AWS VPC Terraform, you can just create like this. Okay, the resource name is AWS_VPC. Okay, so this is the block. Resource AWS VPC, CIDR is this one. You can always give tags equal to name equal to RoboShop, and then environment equal to dev, for example, and Terraform is equal to true. Okay. So I'm creating a VPC. I'm selecting this is the CIDR block and this is the name. Okay, dev environment and then true. So now this will go and then create the VPC. Let us just test this. CD VPC Terraform init. after VPC, you have something called as subnet. Just type AWS subnet Terraform. Okay, you will get AWS subnet, and the syntax is like this. Resource AWS subnet. What is the subnet name? So let us see this till initializing. Okay, done. So now Terraform, I'm going for apply directly, auto approve. Invalid reference. So any syntax wrong here? Tax equal to, need to keep this. Okay, now we will get the VPC. So we got the RoboShop VPC. So now we need to create the subnets. Okay, let me create one public subnet and one private subnet. Okay, so this is, I'm calling it as public. Okay, VPC ID, just AWS underscore VPC dot main dot ID. So we need to select VPC, right? So this is one, and you can get 1.0./24, that is public, and I'm giving private, that is 2.0. Okay, you can keep it here, RoboShop public. I'm keeping it here, RoboShop private. Okay, now let us go for approval directly. So a big network of this one /16, I'm dividing it into two subnets, that is nothing but 1.0 and then 2.0. Why we need to give, when we need to divide into subnets? Just for maintenance and then security. Proper maintenance and security. You cannot keep everything in a single network like this, then it will be very difficult. We can see this in our companies also. HR departments have one network, and then projects have one network, and then CEO have different network. That is nothing but they are into different subnets. So this can be HR subnet. So this can be project subnet, and you can create another subnet for payroll processing. So like that. So logically, you can divide it into however you want. So now two subnets are created. You can just go and then check here. Okay. RoboShop public and RoboShop private. And we need to create internet gateway. Just search AWS Internet Gateway Terraform. Okay. This is the definition. AWS Internet Gateway. So, and then this is attached to the VPC, and tags you can just give the name RoboShop and then apply. Just by name, you cannot call this as public subnet and then private subnet. Okay, so I'm going to create, if you attach public route, so that is nothing but internet gateway. If you attach internet gateway to the public subnet, then it is called as public. If you don't attach internet gateway to private subnet, then that is called as private. That's it, nothing much. So now let us create two route tables. AWS route table Terraform. So this is the route table. Okay, I'm calling it as public. This is AWS VPC. What is our VPC name? That is main.id. So you'll get VPC ID here and then route. So let me take 0.0.0/0 AWS Internet Gateway. And what is the gateway? It is gateway.id. Okay, so one route. So I'm attaching internet gateway to the public route table. So now this is called as public. Public route table will have internet gateway attached. Okay. Similarly, let us create private route table. So now you don't give this route. This is RoboShop public. This is RoboShop private. Okay. That's it. So public route table will always have internet gateway as route. Private route table will not have internet gateway as route. Okay. And then you need to associate public route table. You need to associate with public subnet. Private route table, you need to associate with private subnet. Okay. So now you can just search subnet and route table association. AWS Terraform. Okay, we'll just get this resource. AWS route table association. Okay, I'm calling it as public. Okay, what is the subnet? AWS subnet dot public dot id. What is the route table? AWS route table dot public dot id. Similarly, you can keep this private association and AWS subnet of private dot id and AWS route table private dot id. Okay, so now these two route tables are associated. Okay, so now you can apply. So now you can check here. Public subnet and then done. You can see you have public route. If you go for private, simply we don't attach any internet route. So that is why it is called as private. So obviously people will not connect. Okay. So now let us create one EC2 instance. For example, web instance. So this should be inside public, right? For example, let us take DevOps / practice. DevOps / practice. So I'm selecting this AMI, and which VPC? It's our VPC, not default VPC. So by default, AWS will create one default VPC in every region. Now I don't want default VPC. Okay, I'm going for edit and then RoboShop, and which subnet? Public subnet. Okay. So since it is public, I want the public IP address. You can just enable public IP address and then security group. Select security group and launch instance. So now let us do this one as well. Create one security group. And open only port number 80 to public, and then 22. Generally, we don't open 22 to public. Okay, 22 to open only from your laptop. Okay, so what is the security group? AWS security group Terraform. Now you open this AWS security group, create this one. Now I am giving allow HTTP and then SSH. So here 80, 80, and then CIDR block 80, you can keep it 0.0.0 /0. Okay, V6 remove this. Egress, you need to keep it open, and one more ingress, that is nothing but SSH. It's from internet. SSH from my laptop. Okay, and what is your laptop IP address? That is, what is my IP? If you just give, you will get this one. This is your IP address. So this single IP address, you should always give /32. /32 is nothing but your entire, this is the host, because this is the last one, right? /32. I'm giving 22, 22. That's it. So now I'm making it more tight. You can see this, only I can connect to that, nobody else. Let us apply this. Now we will create one EC2 instance, AWS EC2 Terraform. AWS instance, and then this is the resource definition, right? I'm just naming it as web. What is the AMI ID? Let me hard code it for today. This is the AMI ID. For example, this is t2.micro. So now you have an option to select the subnet here. Where is that subnet? You can see subnet ID. So I want to do it inside AWS underscore subnet dot public dot ID. And you have security group options. Security groups. Okay, you can see security groups. Security groups equal to, it's a list, AWS underscore security group dot name. Okay, so you need to give the names. You can create this as web. Okay, now I'm launching an instance t2.micro, but I'm creating it into the AWS subnet public, and this is the security group, and there will be public IP. You can see public IP address assigned to the instance if applicable. This is the public IP. Associate public IP, because I want public IP, I want to do it from the internet. Associate public IP address. So this is the one. Associate public IP address true. Let me cancel this. So we don't have any instances now. Let us clear and then Terraform apply. If there is something wrong, line number 104. The security group allow TLS does not exist. Where is allow TLS here? Okay. This is this name. AWS security group allow HTTP underscore SSH dot name. Okay. There is simple mistake. here. With name or dot. That's it. It is just name AWS security group dot allowed HTTP SSH, I think. Let us see. So only for security group, they are not asking to refer the IDs. They are asking to refer the names. I think recently it is changed. If you are creating instances in a VPC, use VPC security group IDs. Okay, you can keep this. Use VPC security IDs. This is the one. Dot ID. VPC security group ID, and then AWS security group, allow HTTPS, and then ID dot ID. Let us do this. Okay, it is getting created. Now in the security, you can see only port number 80 to the internet, and this only I can open from my laptop. Okay, at least from my home network. So nobody else can open this. So this is how we will implement Terraform to create VPC resources, subnet. So this is mandatory for any project. If you are going to start, the first task you do is VPC, internet gateway, and then subnets, and then routes, route table, and then routes, and security groups. So you need to do associations also. Okay, so we can stop till here today. So tomorrow, whatever I did like this, we are going to do with our modules. So we will develop a module, Terraform AWS VPC, and then we will use that module to create all our RoboShop resources. Again, tomorrow we are going to use high availability. That is nothing but 2 availability zones, because 1 availability zone may get some natural disasters. It may go down at any point of time due to some technical issue, so that we will always have another availability zone. So in North Virginia, we may have 6 availability zones. Out of them, we can choose any 2 for high availability. Now let us discuss some questions. Yes, Aparna.
Nothing, sir.
Okay, so today's concept of the CIDR, just remember this one. That's it. So whenever you get 10.0.0/16, if you want to divide subnets, try to do like this. Okay, that's it. So I already told you to remember to refer some tutorials from some guy. He's this one, computer networks. Okay, we are not going to learn entire computer networks. At least first 5-6 videos you can see in this playlist. You will get full understanding of the binary system and basic networking things. Okay, CIDR, how we are calculating, how we are dividing that. So you don't need to, that is not mandatory, just convince to this point. So we will get one big network 10.0.0.0 0/16. We need to divide it into multiple subnets. We call few of them as public subnet because public route is attached. We call few of them as private subnets because there is no public route attached. Okay, and then we can have security groups. For tight security, we can decide which one to connect. We can decide which one not to connect. Okay, and then we can start launching our instances. So now, as we said in our RoboShop documentation, so what we said, so we will use only public IP address for the web. So remaining are all we are using private IP address, right? So from tomorrow, I will configure these instances in private subnet so that you will not even get the public IP address. So everything is a private communication. Okay. So if no questions, we can stop here. It's time for you to practice more. Okay. Thank you so much. See you in tomorrow's session. Today evening we can have doubts. Yeah, Murali Chand Tumala.
Sorry, by mistake, I clicked on that raise hand. I'm okay. I'm good.
Yeah,
Thank
it's
you.
okay. Yeah. So if you guys are good, then try to create the resources today. So tomorrow we will use all the possible Terraform concepts, whatever we discussed. We use data sources, we use locals, we use functions tomorrow, we use loops, and then we use modules, we use outputs. We will use every Terraform concept to create a perfect Terraform AWS module tomorrow. Okay, so be ready for that. And then you can publish it into your GitHub and you can ask anyone to create the VPC resources just within few seconds. Now let us destroy this Terraform destroy auto approve. Okay. That's all. Have a nice day. See you in tomorrow's session. Someone have question? Vinith Vijay. Yes, Vinith Vijay.
Hey, good morning, Shiva. I have a question from yesterday, if we can ask you.
Yes, yes. What is it?
Yeah, sure. So yesterday we have created two the backend remotes, right?
Yeah.
So can you just show yours, because I was able to see the one TS-var output file for one of my that it was coming for, but for one of for that remote backend it was not coming. Why so? Not in the AWS. AWS, can you just show me that we have created?
Where is it?
In the AWS account, we have created that remote server and the one for prod. Two.
Yeah, two. Correct.
Yeah. So just open that. We have when you go inside, we have an output where that we downloaded the JSON file. Yeah. Can you just So can you just open it? Yeah. So how we will get this? Because for me, for prod one bucket, it was coming as TV vars, but for another one, which was not prod, which was a dev one, it was not coming. Why it was so?
Okay, I don't understand completely. You need to maintain two. Yeah, you need to maintain two different buckets.
I maintain the two buckets. Okay, one for dev, one for prod. Okay, inside one bucket, I am able to see TVWare, as you can see this JSON file, right? These objects. But in one of the bucket, I was not able to see any of the objects.
Right? That is, maybe you are doing some mistake.
Means how it will come means because we are initiating the we are doing the init. That's why it's coming there.
You should have different backend.tf for the remaining one. For the other one, you should have different bucket and then key. It's your wish. You can keep it different or same. Doesn't matter. Just the bucket should be different. Okay. And keep the locking also different, because if you are working on dev environment, if somebody is creating the resources, you are keeping the different bucket. If you don't keep the different lock, then while they are working on dev, you cannot create production resources. Okay.
So, I will check, Shiva, because I have created all these different Dynamo table also and bucket as well. But
Yeah.
for prod it's coming, but for dev it's not coming. I will check once again.
You should init reconfigure. Then only that will point to the different bucket. If
Okay.
you forget that step, okay,
Mhm.
so do
Okay,
the
I will check.
reinit. Yeah,
Okay,
init
sure, sure.
reconfigure. That's
Fine, Shiva,
so
thank you.
yeah, most welcome. So see you in today's evening QA session. Try to complete this, and yeah, tomorrow we can have a session. Have a nice day. Bye bye.